Okay, come on, introduce yourself.
Hello, I'm Shawn.
Hello, I'm Benny. So, who of you has seen one of our sessions before?
Awesome.
Good. Very good.
So this is I think the 6th phase of the results that we've compiled. And to date, I think we've collected well in excess of over 3,000 videos that we have used in the development of these materials. This new set of phase 6 results is about 700 new videos that we have built over the last about 3 weeks. So we're not going to show you 700 videos. Obviously, we won't have time for that. But
I thought we did.
No. But we've sort of picked some that we think are interesting that we'd like to share with you.
Okay, what we're going to do is...
Well, we didn't say what we're actually talking about.
Well, okay.
What are we actually talking about?
RDP8 and RemoteFX compared to, well, other protocols, but also compared between different versions of the Microsoft protocol.
And we should be clear in here in the terminology because the Microsoft guys make this very confusing for us. Microsoft uses the moniker RemoteFX to talk about the whole graphics user experience within the Windows environment when you're remoting it and all that kind of stuff. And RDP8 is just one protocol implementation that is part of RemoteFX, much like RDP7, 7.1, that kind of stuff. But I sort of like to differentiate them only because when Microsoft originally came out with RemoteFX, it was a virtualized graphics technology. And by the way, you can get into a lot of debate with different people in the graphics industry of what actually is a virtual GPU and what actually isn't a virtual GPU. So what Microsoft implementation actually is something called API intercept, which is a little bit different than a virtualized GPU, and we'll get into that a bit later.
Good. So what we're going to do is very briefly talk about how graphics promoting works and how RDP and RemoteFX work. Then about how we set up our test labs. We invested a lot of time and effort to build 2 test labs that are pretty similar on both sides of the of the big ocean. One in Europe and one over here in the US. And we're going to present you 2D test results. So that's going to be the majority of videos that we will be showing. Then we're going to go to the 3D graphics remoting and show you the results of of those tests. And in the end, a short summary.
Yeah. And we're going to cover the intro to this very quickly because some of you have seen this presentation before, so we'll skim through that very quickly. Yeah. And then we'll do a bulk of the presentation will be video results.
Yeah. Good. Hey, you want to take that?
No. Ha! I got a lot of talking to do when we do the videos.
Oh,
so
okay.
You talk now.
So what I've done here, I created this slide because sometimes it's really confusing what happens when you do graphics promoting on top of a hypervisor. So I put that all together in one picture, and it was inspired by a slide that was first used by NVIDIA. And so you have the hypervisor down here, and on top of it you have the virtual machines running. Well, it can be client VMs, so to say, so the workstation VMs or the server VMs. So either Win 7, Win 8, or Server 2012, RDSH. And you connect to a client machine through a remoting protocol. That's all in one picture, and we're going to use the same picture again when we will introduce the 3D graphics remoting using hardware acceleration. Good. Now, if we look at RemoteFX, what it basically does in version 2, it differentiates between 3 different graphics formats. And one is text, one is still image, and the other is animation or video. So I did some color coding here. So the blue is the text, the red is the still image, and the green is video or animation. So what happens then is those 3 different formats are treated separately. So you can see there are like 3 different pipelines that deal with the different formats. And in the end, they're brought into the RDP protocol and transmitted to the client. There's one exception to that because you can redirect video. And it depends on the network conditions if video is redirected or not. It not always works as expected, what you will see later in our videos. So this media stream goes through a separate virtual channel to the client side. On the client side, what you do is you receive everything, and you have this not redirected media. So you have those 3 video streams that come through RDP, 3 media streams that come through RDP, text, still image, and video. So that's the upper side of things. So you use the CPU or a DSP to decode and display everything, or you have this redirected media content, which is treated separately.
And to be clear,
so
the redirected media that we're talking about is classically the same as MMR in RDP7. And that is, of course, restricted to Windows media types, not generic Windows media, not generic media redirection, but specifically Windows media content.
And just to give you an overview of some of the details of RemoteFX, so it can use UDP. That is something that is very important, in particular for the RemoteFX graphics and audio-video animation streams. It uses TCP for the peripheral, and the media redirection is still on TCP. The good thing is that they constantly monitor now the bandwidth, and they adapt dynamically. And that has been introduced with RemoteFX version 2, which makes it a lot better compared to the previous version. And they also monitor latency and jitter, and the default frame rate, as it says here, is 25 frames per second. Well, the video is based on an H.264 encoding and decoding technology, so they're using rather standard things that they modified to make it work better for their particular requirements. Anything else we should do? No?
That's good.
Good. Now, looking at the setup that we have in our lab, so the idea is that we have a host machine with all the necessary test machines installed, the virtual machines installed there. So either Windows 7, Windows 8, or Server 2012. And so we have scripted test runs on those machines, on those virtual machines. We have a client to connect to those virtual machines, and on the client we see what the result is when the protocol goes through the wire. Now, in order to be able to record our tests, we connect to this client machine through an Epiphan box. The Epiphan box is something like the projectors that are here. So you take the video signal and feed it into this box, and this box converts it into a signal, USB signal, that is similar to a video camera. So you can attach yet another PC to the output of the Epiphan box and record the video. So in total, this looks like that you have the client machine connected through USB to a recorder machine. This recorder machine records the raw video files. And between the client and the host, we have a WAN emulator. We're using the Opposite box, the Linktropy Mini 2 as of today. We're going to change that in the near future because we want to have a more powerful WAN emulator. But as of today, we are using the Linktropy Mini 2. Yeah, and it allows us to configure different network settings.
For phase 7, we're switching to a apposite Netropy N60, which gives us gigabit speed emulation, multiple test scenarios. And we're also switching the Epiphan DVI USB to a PCI to USB, PCI DVI encoder that will give us much higher frame rates, much higher resolution. So we'll be able to do some more complex tests than what we do today.
Because now that we started recording high-end graphics, we see the limits of this box. Because if you have high-end graphics created in many, many frames per second, this box cannot deal with that. So it goes down to like 10 to 15 frames per second. So we introduce artifacts into the videos that were not there on the client. So this is why we need better hardware for that. The network emulation settings are, we have LAN settings, we have settings in the range of 50 milliseconds latency, different bandwidths, typically a packet loss that is very small, except for some of the scenarios where we added substantial packet loss in order to see how the protocols can deal with that. And we have those 200 millisecond to 300 millisecond latency setups. So the 50 milliseconds is if you stay within a continent. The 200 milliseconds is if you go across continents.
And that's actually probably a bit further. So the emulation scenarios that we did, at least for US based, 50 milliseconds will get you anywhere within the US. You know, East Coast, West Coast, 50 milliseconds
Same
is
is true
more
in
than
Europe.
enough. Typically, intercontinental between like the US and Europe is only around 90 to 120 milliseconds. The 200 milliseconds is more sort of North America to APAC type latency. So we wanted to make sure we're testing those scenarios as well.
This is one-way latency?
This is round trip.
Round trip.
Yeah.
So after recording the raw videos, so we have the raw videos in a fairly high resolution. It's 1260 by 1024.
1280 by 1024.
1280, yeah. And so we reduce the resolution and we make sure that we have a fixed bit rate. Because if we use the raw videos, some of the raw videos are like 300 to 400 meg. It's always 45-second videos. So creating that huge amount of data is a big challenge. And if you want to run them side by side, you want to make sure that it's fair. So we re-encode them with a fixed bit rate and with a reduced size so that they fit nicely into a 4-up player, which allows us to run 4 videos side by side, or 2 videos plus additional information. You will see that later. So we can also inject the pictures of network conditions, so that you can see 2 videos plus the information regarding the network. So this is how we do it. So it's many steps that are included here, and this is why typically it's a very short night before presentations like we do it today. So last night, I think I was up until 2 o'clock to put that all together. This morning we met very early to finish everything. So, because it's a lot of raw material. Right. So, let's just do it and dive into that. Before we really do that, I want to make you familiar with what the 4-ups look like. So you have, well, you will see it, what I did here. I wanted to make sure that you understand that we have a top left, a top right, a bottom left, and a bottom right. So it took me a while to record those videos. So it was a fun afternoon because typically people get overwhelmed when they see 4-ups the first time. And so I thought I'd make it a little bit simple for you guys to get adjusted to those 4-up scenario. Yeah, my son came into my lab and he thought that I got nuts. So. Good, but this gives you an impression. So, as Shawn pointed out, we have multiple faces. And as a recap, here is something from phase number 4. And that happened between last year and this year. So it's all happened in the time between BriForums. So the first thing that I want to present to you is the QuickTime comparison between Windows 7 RDP 7.1, Windows 7 with HDX 5.6, Win 7 on RDP8 with TCP, and Win 7 RDP8 with UDP.
Let's be clear,
Yep.
The differences between the TCP and UDP, we actually forced RDP8 to use TCP only to make sure that it would not use UDP. The default is use UDP and fail back to TCP, so we enforced it.
Yep. So, and we use it on 2 megabit 50 milliseconds. What we wanted to show is how much RDP7 sucks if you compare it to RDP8. But with this network conditions, you will see that RDP8 TCP and RDP8 UDP, you almost cannot differentiate between the two. Because UDP cannot benefit, or cannot give you any benefit, because there is no packet loss.
This is 0.01% packet loss, so it's typical corporate MPLS networking with very, very low amounts of packet loss. So the UDP versus TCP is not going to give you a huge differential benefit. As you start pumping latency up, or if you start introducing higher amounts of packet loss, that's where the UDP will actually start to really benefit.
And you see also in the upper right that HDX performs pretty much in the same way as RDP8 does. Good, but now let's introduce some packet loss at more latency. And now you're going to see the difference, what UDP can make. Yeah, it takes a while to establish, even though it's 12 megabit. You have 300 milliseconds latency and 1% packet loss now. And you can immediately see that this runs a lot smoother than that one. So this is TCP, this is UDP, and even HDX is struggling because it's also based on TCP. I mean, if you look at RDP7, it's completely unusable. So it's not a video what you see there.
Everyone seen this RDP7 tile-based painting before? Anytime you try to use RDP7 over a WAN, it's quite painful.
So this was one of the things that we wanted to share with you before we dive into the newer scenarios. And the other one is, what does it look like if you're using DirectX 9 with HDX 3D Pro so that you have a dedicated GPU, and compare it, which is not really fair, but compare it to PC over IP and to RemoteFX soft GPU.
A vGPU.
vGPU. And it's a shared GPU scenario, but just to give you an impression what the difference can be. And we are gonna, for this we use the grid card, and we have a grid card over here, but we will cover that later. But you see the difference. You have like 1,000 frames per second in the upper left. You have like 30 frames per second upper right. And you have 60 with RemoteFX. RemoteFX does a real good job here because, well, you're comparing different things because one is a dedicated GPU that is running, while the other is a shared GPU. And you see, it was stuttering. It stopped for a while, and it recovered. So this was reproducible in the lab. So it's very interesting what's happening there.
No, this is 2 meg, 50 milliseconds.
2 meg, 50
So this is a WAN condition. The thing to keep in mind with this is the upper left corner, which performed great, is a GPU pass-through, 1 GPU per user. So it's like a VDI desktop, and that user has the entire GPU core. These other models here, these are shared GPUs. So this is PC over IP, VSGA. So it's a shared API intercept graphics model.
And even though it says it renders 1,000 frames per second, it does not deliver 1,000 frames per second. But you see the difference when it comes to rendering, how much faster it is if you have a dedicated GPU. Later, we even compare with bare metal because we want, that's the ultimate goal. We want to be as fast as we can be with bare metal, also in a remoting scenario. Right.
And can you test it with HDX or Z7?
Yes, we have results of that. We'll be showing that after the 2D results.
Good. So those were phase 4 and phase 5 results. We have many more of them, but we just wanted to handpick some of those. And now, in order to make it a little bit simple for you to compare the individual protocols, we put together, or we against each other, RDP7 and RDP8, and use a WPF scenario on the LAN. And what you see here is not only what it looks like, you also see what happens on the network. And now look at that. RDP7 using up to 50 megabit per second in a LAN scenario, while RDP8 over UDP goes down to like, well, 5 to 6. So it's a big difference.
And the user experience in both cases is pretty much comparable. You don't really see a difference in the user experience over the LAN. Now, we're not doing any kind of network latency and that kind of stuff, but if you compare straight RDP7 to RDP8 with UDP transport, you've got a fraction of the bandwidth. And this is true in almost all tests that you'll use RDP8 against RDP7. There are a few circumstances where RDP8 will use more bandwidth because it's more aggressive. But for the most part, I'd say 80 to 90% of what you would do will be less bandwidth on RDP8.
But 10 times more, that was really, almost 10 times more, that was really impressive when you compare those two. Now, let's do the same thing for video. And this was a result that really surprised us, because according to Microsoft, RDP8 was supposed to do a re-encoding under those network conditions. And obviously, it doesn't do it, because you see, the results are similar. So both of them do an MMR, multimedia redirection. And we had this conversation with the Microsoft guys, and they confirmed that this is a bug, and it will be fixed with the next release. So that was really interesting to find out for us.
The results
we thought we did something wrong, so we went to the RDS team and asked them, hey, look at that.
The results are very different in Windows 7 versus Windows 8. And Microsoft made a number of improvements in the core graphics subsystem in Windows 8 that allows it to do much better job at some of these things. But in the case of Windows 7, and we do most of our testing with Windows 7 because honestly that's a majority of what's deployed in enterprises today. We didn't want to do too much Windows 8 testing because enterprise adoption is actually very, very low right now. We have a few test results of some Windows 8 and Server 2012 stuff, but we're primarily focused around Windows 7 on the desktop.
Yep.
But the important thing here is it is doing MMR, and on the LAN that's kind of what I'd expect to see happen. On the WAN, however, we would expect to see some of these videos encoded in H.264 and delivered, but what we found on Windows 7 is it's very hit or miss. So I'm guessing that there are some bugs in the way that Microsoft is doing network detection, that in some cases it thinks the network is better than it is and it's performing MMR when it should be doing a transcode of the video.
Yep. So the next thing we wanted to do is to compare HDX versus RDP8. First on the LAN, and later doing the comparison in WAN conditions. So do the QuickTime. We're going to do the QuickTime video again, comparing the two. And if we thought that RDP8 is already doing a great job with the video, with the QuickTime video, look at that. HDX does an even better job. But they introduce more compression artifacts.
Yeah.
So they are more aggressive with their compression. And this is why they're using less bandwidth for obvious reasons. So it's up to you to decide. What do you want? You want to provide more bandwidth and have a better user experience, or you're bandwidth constrained?
I think the important thing is in LAN conditions, it's probably not really that important. Although there are certain scenarios that we've shown you guys under RDP7 where RDP7 will take up to 50, 60, 70 megabits on the LAN. And that can actually even be a problem for normal corporate environments because your core distribution switches, depending on how much bandwidth they have, if you've got 1,000 users using 70 megabits per second to watch content, that can overload your core switches. So it is important even on the LAN, depending on how much bandwidth they use. Question? Yes.
Oh.
Yeah, we did not tune the quality parameters for RemoteFX
Yeah,
or
the
RDP
question was
on the
about
host.
tuning. The question was about tuning. Did we tune something?
We did
No,
not.
we didn't.
We left everything at
Yep.
defaults.
Yep.
Correct,
Yep.
correct. We did not. The intention that we always have with these things is to try to see how well they work out of the box without requiring tuning. And the reason why we do that is for a long time ago when we did like phase 1 and phase 2, we were doing a lot of tuning, particularly of HDX and PC over IP and these kinds of things. And what we ended up realizing is that a lot of admins and a lot of end users don't understand the network conditions they're coming across, so they don't know what to tune for, and therefore they make the wrong choices. So our idea was try to make it out of the box work as best as possible, and of course you can tune these to make them better, but we wanted to see how well they worked kind of out of the box.
In the first video, you were testing against Windows 7. Was
Yes.
that always with the virtual GPU or not?
No vGPU. This is just straight up RDP.
Yep.
So this was not RemoteFX.
Correct.
Yeah.
Yes, just RDP. But again, that goes back to Microsoft calls everything RemoteFX, but then they differentiate, you know, whether it's
What about RemoteFX? I mean, if you don't have a virtual GPU with Windows 7,
Right.
you don't get RemoteFX. The only support is
correct.
you have it as a virtual machine and Hyper-V with the virtual GPU.
Right.
We're going to discuss
again,
that later
that's-
because it's tricky.
And you got to make sure you're connecting with LAN settings.
Correct.
Yep. Correct.
Yeah, we don't have screenshots in here of the different parameters that we're choosing, but in RemoteFX, what I call RemoteFX V1, the one that shipped with Windows 7 and Server 2008 R2 SP1, that RemoteFX version or that variant you could only choose LAN connection settings in order to establish a RemoteFX connection. If you chose anything other than LAN, you would get classic RDP. There was no RemoteFX vGPU capability. So it is somewhat frustrating, and some of that's been made better with Windows 8 and with RemoteFX RDP8 solution. It's you don't have to choose the LAN setting for that anymore, but it's a different configuration.
Let's cover that when we
sure. Yeah, we can cover that.
3D stuff. Okay, now I have a flash scenario, HDX versus RDP8, and I mean, look at that.
Now, we should be very clear on why these results are so different. So Citrix is one of the only solutions on the market that has client-side flash fetching. So we're monitoring bandwidth between the host and the client. So in this circumstance, in the HDX test, the client machine is fetching it directly from the internet. It's not connecting back to the hypervisor VM at all, other than some control channel bandwidth. So this flash experience is actually pretty good, and we're using marginal amounts of bandwidth. Whereas in the case of the RDP8 solution, because this is so graphically intense, such a high frame rate, you're having a lot of bandwidth consumed.
I mean, this is the most graphics intense flash animation we were able to find, and this is amazing. I was amazed how good the RDP protocol was able to deal with that kind of animation. So it still produced in the range of, how many was that?
About 20
frames per second. And deliver 20 frames per second. This is amazing. So
the only problem is, even though it delivers 20 to 25 frames per second, because of the rate of change in the graphics, it ends up creating it very blurry. You get very, very lossy compression, which is hard to see in these quarter-sized video screens. But when RDP8 processed that 25 frame per second flash, it was very blurry.
So you'd expect that to be transcoded as the image?
Correct. Yeah. What's up?
I mean, there's almost nothing you can do to predict what the next image is going to look like, because the animation is so fast and it's random movements. So they have to retransmit every individual image. And here's another thing with Whack-A-Mole, Sean's favorite game. It's the same thing. Flash. If you run it on the client side instead of running on the host side, that's a major difference. Even though the user experience is great on both sides.
But this isn't a LAN scenario. Yep. When you take a flash game like this over some higher WAN parameters, then the experience degrades when you don't have client-side flash.
Now, we introduced 8 megabit 50 milliseconds as a new network condition, and now we're going to take a look at the flash thing again. And now you will see the change. So again, this runs locally, and here it's under constrained conditions. So now it cannot use 80 meg to deliver the individual frames, and this is what you get. But after a while, it's not bad. Obviously, they're doing smart stuff. But you can see it's blurry. As Sean said, they introduce massive compression.
Is flash duration V1 or V2?
This is V2. Yeah. V1 doesn't work over 30 milliseconds of latency, or 30 to 50, depending on how it's configured. This is V2. This is actually, in the case of the left-hand side there, that's Zen Desktop 7.
Yeah.
So
latest and greatest. Okay.
So are you expecting that the improvement in the performance of RDP8 on the right-hand side was the H.264 codecs improving?
They adapted.
Well, the H.264 transcoding applies to video content when you have image content that's a progressive renderer, so it's not actually a video transcode for that.
But that was video transcode.
I'm pretty certain that's just image.
What do you think? Do you think it was animation or still image? It's animation. Yeah. So animation and video are treated as identical in that case.
In most cases.
In most cases. Yeah. Okay. Good. Good. So let's get into your scenarios.
So let's cover some 2D scenarios. And in the 2D scenarios, we have, how do we get the, okay. In this one, we've got 12 megabits per second, 300 milliseconds of latency, and 1% packet loss. And you'll notice that RDP7 over here, completely unusable. RDP8 over UDP actually performs quite well, and because of the fact that it's UDP-based, you're going to see some very smooth experience, even though you're having 1% packet loss. And the HDX solution up here running Zen Desktop 7 actually does a pretty decent job, even though TCP-based protocols typically don't do that well with packet loss. And then up here we have a bare metal solution, which is of course the ideal user experience. But you can see here how the HDX one is degrading because of the high latency and packet loss, whereas this one's actually still quite smooth. Again, UDP lending a hand when you have packet loss. So it's actually quite nice.
And here you can see for the first time, looking at the bare metal, because it's not as smooth as you would expect it to be on a local machine, on bare metal. So this is due to our video recording hardware that we have today. This is why we had to invest into new hardware, because we found out, we need to make sure that it really looks good, that we have like 30 or 60 frames per second for the videos. But that's going to be a challenge to play back 4 videos simultaneously, because then you need to provide the, enough power to do that.
Yeah.
So the question is UDP actually valid in remote scenarios?
So that's a great question.
Questions
and
about
the answer,
using UDP.
So the question was, if you have a UDP-based transport protocol and you are connecting people through some form of, let's say, an SSL VPN or something like that, what is the impact of that? And the answer is that sort of destroys the experience, because where UDP gets its benefit from is the fact that you don't have to ACK your packets. And if you're doing wrapping it inside of an SSL VPN envelope, then you lose that capability. And if you have packet loss and retransmits, it will impair the UDP experience. Now that being said, almost everyone that does some form of UDP, like RDP8 is now supporting UDP, and VMware PC over IP, they have their own custom gateway solutions that can do UDP proxying from an external DMZ. So in those circumstances, if you use their solution as opposed to your own SSL VPN, you can still have a decent experience, even though you're connecting them through some form of a gateway proxy. So it depends on what you use.
Do you know if the Netscape gateway supports UDP?
Well, Citrix only uses UDP today for the real-time audio transport. They're not using it for any of their transcode video delivery. So they're still going to be TCP-based for that. So no real benefit there.
Okay. Start that one.
So in this one, again, we have bare metal. Again, no network connection at all. Here we have the Zen Desktop one. You notice this is not quite as good as bare metal, but we're still having a very fluid user experience because we have client-side flash. So we're basically not going across the network for that. RDP7, completely unusable, not even, I think it says like 0.1 frames per second, which is fantastic. And then RDP8, actually doing a good job, but it definitely cannot compete with localized flash. Oh, so that's a good question. So the reality of this is, on the bare metal circumstance, this is a quad-core CPU, and it has a K5, NVIDIA K5, K5000 card.
Yep.
And depending on your flash configuration settings, you can 3D accelerate the flash content to some degree. Here in this circumstance, this is a dual CPU, Core 2 Duo client machine where the flash is getting rendered, so it's more powerful on the bare metal than it is on this one. And it doesn't have a GPU. It has an Intel integrated
the
video
reason
card,
why we
so
did
that is why it's slower.
We put that high-end machine together because later with the 3D tests, we wanted to compare the same thing, the same Kepler GPU on a client, but the Kepler GPU in a K2 grid card to make it fair.
But
Here,
that
in this
is
case,
a great
it's not
question.
fair because this client machine, the bare metal machine, is by far more powerful.
So to respond back to what Dan was saying,
Yep.
if this was the same client PC, the experience on HDX flash redirection should be identically equal to this bare metal one.
Yep.
So sorry about that. We should be more clear that this is different hardware.
It's pretty much the same as pre-RDP7.1 because the graphical colors are being used is pretty much GDR remoting.
Yes.
It's not RemoteFX or RDP7.
Again, none of this is vGPU.
Yeah, I know. But on the right, there's something very interesting. In Windows 8, they enabled the software encoder for recording.
Yep.
Yes, we're going to be
Yep.
covering some
Yep.
of the soft
Yep.
GPU. So we'll get to that. Do we need to skip through some of these along the way?
What do you want?
Let's go down to this one.
Yeah, you've got another like 15 minutes for the
Okay.
for the 2D scenarios.
So some interesting things happen here, and we're still not exactly sure why the water
It's
color
very
in some of
simple.
these
It's
turns out to
blood
be
in
red.
the water.
We think maybe there's a shark in it, whatever. But in a bare metal situation, the water should be blue. You get the nice water effects. Again, this is a GPU on it, so it's not a quite fair comparison. But in these where there's not a GPU, Zen Desktop 7 is saying it's getting about 23, 24 frames per second. You can see the fish fairly fluidly. And again, this is 2 megabit, 50 milliseconds. Down here, RDP 7.1, it was a very, very poor user experience. Even here, with the UDP-based transport with RDP8, not doing very well, and the reason for that is because the 2 megabit becomes limiting with RDP8. We need more bandwidth than 2 meg to run this test effectively. So what we can do is take a look at how that test would look if we increase our bandwidth and go up to an 8 megabit network pipe. And even the 8 meg network pipe doesn't completely fix RDP7. It's a little bit better, but the frame rate's still quite low. Under RDP8, you're now seeing we're getting a resultant frame rate that's pretty close to matching what the HDX solution is using. And more importantly, we're seeing fluid movement of the fish in the fishbowl. So given enough bandwidth, and again, what we've been seeing in our testing is it's about somewhere between 30 to 50% more bandwidth of most of the similar HDX results.
From here, it looks like perhaps progressive rendering is kicking in, because there's some blurring of the red.
Yes.
Yeah, you can see some pretty heavy artifacting.
Yes.
I would expect that progressive renderings would be in play there, unless the rate of change was.
I don't think it's progressive. I just think it's different. It's heavily compressing it. I mean, progressive only kicks in when the content is static.
Right.
Not while it's
But
active.
it exact should be considered a still image.
Yeah.
Right.
Let's go back.
Yep.
I want to jump into this one, an HTML5 test result that's actually quite interesting. So this one starts out kind of slow. There's not a lot of movement, so most of the screen is fairly static. So there's not going to be a lot of bandwidth used. But as the animations start, this is 2 megabit, 50 milliseconds, and you see that you have a lot of stuttering with the RDP7 solution. Also, the RDP8 solution also stutters quite a bit when compared to the HDX solution. And a lot of this, again, is 2 megabit is not enough for RDP8 to deliver a good experience with the motion graphics that we're using here.
RDP8 on Win 7. We're always talking about Win 7 here. To be very clear, things may look different on Win 8. So that's the lessons that I learned.
So again, if we look at that same thing and now increase ourselves to 8 megabits of bandwidth, you now notice that the RDP8 solution does get quite smooth video, and even RDP7, given 8 megabit, performs quite decently. And then the last one we want to show on Monster is when we increase the latency to 300 milliseconds and introduce 1% packet loss. What you notice up here is that the HDX solution is actually beginning to stutter in some cases because of the high latency, because of the packet loss. So this is a circumstance where the UDP-based transport in the case of RDP8 is actually doing a pretty decent job here, whereas the HDX solution being TCP-based is having more stuttering. So when packet loss is involved, of course, the UDP-based solutions kind of help you out quite a bit there.
Is this a video or some sort of WebGL demo?
This is HTML5.
So this is WebGL or something like that?
Yeah, no, it doesn't require WebGL because that would require a GPU. This is not GPU-based.
It doesn't actually require GPU.
Not always, of course, yeah. So let's do WMV HD and take a look at that. And we had some interesting results with Windows Media Content because the default configuration of RDP7 is always going to be to try to MMR the video, so you're going to get very, very slow results when you're bandwidth constrained. This is 2 megabit, 50 milliseconds in all of these results here, and both RDP7 and RDP8 are both doing MMR in this circumstance. So that's quite interesting because there should be circumstances with this where we don't actually perform MMR.
One clarification, RDP8 on Win 7 always does MMR, only in Windows 8 does RDP8. Lower bandwidth or higher latency, they can switch back using transport.
So good reason to use Windows 8 in that circumstance.
Or you can disable MMR.
Yeah,
Simple to disable MMR
and fall back to host side rendering.
Is there any chance that we will see another sort of implementation of RDP8 for Win 7 in the future that goes beyond what we see today?
None that I know of.
Okay.
That would obviously involve a lot more
Yeah.
work than
Yeah.
just.
Yeah, I can imagine because to be very clear, the graphics system, the graphics stack in Windows 8 is fundamentally different to the one in Win 7. So the graphics system on Win 8, well, it is very good for remoting scenarios, and you have to add that to Windows 7 because it was never built to be like that. And that makes it really challenging for Microsoft to sort of backport all the functionality to Windows 7.
We also have an interesting result here. We have this JavaScript photo gallery, which is, of course, makes a high amount of graphical change on screen. And of course, RDP7 painting, block at a time, not really usable. RDP8 in this circumstance actually doing a pretty decent job, even given the fact that it only has 2 megabits of bandwidth available to it. Likewise, HDX doing a very decent job. Both of these pretty close to bare metal experience, even though they're going over a 2 megabit network, whereas bare metal has no network involved. It's just local graphics. And I want to also cover the Silverlight Deep Zoom. Now, Benny and I have a bit of a glitch with this Silverlight demo that we didn't notice when we were first building these tests. But the way that we're performing the coordinate zoom ends up zooming a different location. But what I wanted to show that's interesting about this is that on a bare metal situation, you have very fluid zoom in and zoom out. On the 2 megabit solutions, we have definitely a little bit of delay in the frame rate where you can notice the stuttering that's occurring. And typically the reason for that is because the video, the bandwidth that would be required to deliver it smoothly is going to be greater than 2 megabits per second. So you end up getting a bit of slowness in there. What's that?
We love the painting.
The painting?
The painting?
Yeah.
Well, that was the alternative to the other demo that I wanted to do.
Yeah, I think it was better that we used this one. Oops. So what we then also tried with the Silverlight Deep Zoom is to increase the bandwidth to 8 megabits to give the particles a better chance at providing a more fluid user experience. So up here again we have bare metal as if it's running locally on the PC, and then here we have HDX, and down here we have RDP8. And again, RDP8, even with 8 megabits of bandwidth, is providing a little bit more stuttering in the experience. Whereas HDX, you can notice, even though these are zooming different spots, there is absolutely no user experience differential between running this over an 8 meg network versus running it local. You see pretty much the exact same look and feel, which is quite nice. Okay, do we want to, I don't know how we are on time, do you want to jump into?
You can have another 5 minutes for the 2D
cool.
stuff. Yep.
So I want to
We're
also
good in time.
cover
We're good in time.
a Flash HD video. In the case of Flash, again, we're going to have a great experience in HDX because of the client-side Flash content fetching. So in the case of Flash, we've got a very fluid video here. In the case of RDP8, because of the constrained 2 megabit 50 milliseconds of bandwidth, we're getting a stuttering user experience again. And at RDP 7.1, as I said, completely unusable, something that you definitely could not actually watch this video.
But look at HDX, you almost cannot differentiate between the two. Yeah.
Yeah, because again, this is client-side
Yep.
Flash fetching, so it's basically the same as if it was bare metal.
One note about client-side flash direction Citrix. I found that in many projects, the endpoints, when you deploy a Citrix solution, are not really up to speed with it. Great flash rendering, CPU, you have CPU.
Yeah.
Yep.
So I should bring up a point about that. While client-side Flash is a great technology and provides a lot of good experience benefits for Flash, the important thing to remember is that it does, of course, depend that the client-side machine has a Flash player, that it's a version that matches a supported version, that the person has an internet connection that allows them to pull that data down faster than rendering it host side. And most importantly, if you do client-side Flash fetching, you have to keep in mind that you do have the exposure potentially of exposing the client-side machine to a vulnerability. If you direct the person to a Flash content on your host environment, you can compromise their client-side Flash player with that redirection. So there are some risks in doing client-side Flash, but the user experience is actually quite good. And then the last one I want to show is the Flash HD video now with 8 megabit. And of course, the client-side flash is going to perform just like bare metal because it's doing this effectively the same thing. But now that we've got 8 megabits of bandwidth, you're now able to see that RDP8 is actually performing a pretty good job at this, even though it's host-side rendering and transmitting that across, whereas RDP7 is struggling a bit, even with the 8 megabits of bandwidth. And a lot of this can be explained if you looked at some of our earlier 2-up results comparing RDP7 to RDP8, that RDP8 in most cases uses about 1/10 of the bandwidth. So when you are constrained even to 8 megabit, if RDP7 was trying to push 60 megabits per second, it's not going to work well when you constrain to 8, whereas RDP8 does a great job with that.
Before we jump to the 3D stuff, just to give you an impression how we do the testing, because all these video recordings, how we do those. So here in this machine, I have a client Hyper-V running, and I have 2 of those test machines, Windows 7 and Windows 8 running on that. And that's exactly the test setup that we have in our lab as well. And here's a Windows 7, here's the Windows 8 machine. And if I just start like one of the scenarios, this is what we typically do. We give it the scenario number. It's an Autoid script that runs, and at this stage I click both enter on the client side and enter on the recording machine to record the 45-second video clip. And you see here on Windows 7 I cannot run that particular demo because it's not supported on Windows 7. While if I do the same thing on Windows 8, it does its job. And here it's soft GPU now. So it uses RemoteFX soft GPU. So you see the performance here. As I said, this is the way we record those videos. So you sit in your lab and you do the same thing every 45 seconds over and over and over again. So our wives, they find it really funny that we are watching the same videos again and again. And now I hired my son. He's 16 years old, and he wanted to make some money in the summer break. And I said, okay, now you sit down and you click here, and that works quite nice.
I think I need an intern.
Good. Let's move on.
So we want to talk a little bit about graphics and how more high-end 3D graphics impacts the virtual desktop scenario or terminal services scenario. The important thing to think about, though, is that there's different categories of people and what level of graphics they're going to require. So if you think about the typical task worker, most of what they need to have is some fairly basic stuff in terms of Windows Aero. If you're using Windows 7, you want to support Windows Aero glass theme. That would be something that a typical task worker might use. They might also use some very, very low-level graphics that is DirectX 9 type stuff. It's some very, very low-level stuff. And a lot of that can be done with software-rendered graphics. So soft GPU solution, like in the case of RDP8, supports soft GPU under Windows 8, or in the case of PC over IP, has their SVGA 3D solution that can support Aero. That's pretty much all you really need to cover for a task worker. When you get into a knowledge worker, you're going to require some higher level of graphics performance, and the higher level of graphics performance means you're probably going to have some form of a GPU on the host machine. And we covered kind of knowledge worker and power user. This might be something like PowerPoint uses DirectX 10 animations in PowerPoint 2013. So if you want to have a fluid experience when you're doing your slide animations in PowerPoint 2013, you're going to need to have some form of a GPU to support that. So knowledge workers and power users can get by typically with API intercept. And API intercept today is supporting DirectX 9, DirectX 10, and DirectX 11, depending on which solution you're talking about. So RemoteFX is supporting all of those. When you get up in the power user situation, this is where you're going to have more advanced graphics formats that you need, like you're doing Photoshop, you're doing some things that are requiring more graphical intensity.
For the designers.
Well, some of that can also bleed into the power user category.
Yeah, correct.
But when you get up in the designer, this is really where your CATIA type stuff is, CAD engineering applications. And that's really where you're going to want a dedicated GPU per user, or potentially down the road virtualized GPU support, which is not currently capable. And as I said, this is something you can kind of debate depending on which side of the coin you believe in, but Microsoft calls the RemoteFX vGPU, it's virtualized GPU. Whereas the NVIDIA perspective is that that's really kind of more like API intercept. It's not actually presenting a virtualized graphics processor to the individual
This is
VM.
why I had to modify this title several times to make sure that we are talking about the right thing here, that we don't confuse people, because vGPU is used in different ways.
So to clarify, this is API intercept.
Correct.
Yeah.
Correct. So what you do is, well, you have your drivers that come with the hypervisor that are inside the VMs, and you cannot add an additional driver that is talking to your GPU into the VM.
So in the case of the API intercept, the hypervisor is actually sharing access to the graphics card. You're not actually loading an NVIDIA driver inside the VM and having direct access to a real, so NVIDIA provides access to CUDA and that kind of stuff, but you can't expose that when you're doing API intercept. You can expose it when you're doing true virtualized GPU or doing direct dedicated GPU pass-through.
Is there a list of which APIs are allowed through? So like with DXL, we get programmable shaders and stuff like that, and that's when we start hitting CUDA, OpenCL, that kind of thing. Is this published somewhere? Do I know what APIs I can intercept and which I can't?
It's on the NVIDIA site?
Oh, really? Okay.
Are you covering that also for RemoteFX or no? Okay. So does Microsoft have something about what you are covering?
In terms of specific feature sets that the GPU exposes?
Yeah.
No, we don't have a published list, but we thought I'll do this run a little bit more.
Okay.
Was which case there's no question. We can chat.
Okay. So here are the requirements that you need if you want to use RemoteFX vGPU, SLAT and DirectX capable GPU, and full installation of Server 2012 and Hyper-V and RDP8. And it requires Windows 7 Enterprise Service Pack 1, including, well, no, not including the KP patches.
Yeah.
That was the thing that I did wrong, because in my lab, I installed everything. Windows 7 Enterprise Service Pack 1, I installed the RDP8 knowledge base patches, and I tried to connect from my Windows 8 client machine. And I never had vGPU until I found out that I have to uninstall the KB patches in order to fall back to RDP7, and then it would use RDP7 RemoteFX vGPU. Whoa, this is really complicated because I don't think it's documented anywhere. And it confused me because I thought I installed all the latest stuff and it just did not behave the way I expected it to be. While in his lab it worked, but the reason was he used a Windows 7 machine without the KB patches installed. So during the negotiation, there was no RDP8 support on both sides, so it fell back to RDP7, even though he had the KB patches installed in the VMs. So we had different results. And I was like, what am I doing wrong? Because I always compared only what we did in the virtual machines and not what was the client.
I think the two most important things about RemoteFX vGPU in Server 2012, go back.
Oh, excuse me.
The two most important things you need to make sure you know is that you must have a DX11 capable GPU. The RemoteFX V1, or what I call V1, that was in 2008 R2 SP1, supported DX10 graphics cards, but now in the Server 2012 edition, it's only supporting DX11 graphics cards. So you must have a fairly recent modern GPU to support that.
We had good graphics cards.
Yeah, we were originally using Quadro FX 3800s, but those are not DX11 capable, so you can't use those with RemoteFX 2012. The other thing that's important to know is that you cannot do vGPU with any edition of Windows client other than Enterprise. So there's some reason why Microsoft decided to tie that only to Enterprise Edition, but you cannot use Professional or whatever. A MacBook Pro?
Yeah, with the NVIDIA card, that's a MacBook Pro.
Yeah, makes sense.
Yeah, coming back to NVIDIA. NVIDIA was so nice to give us K2 cards, plus they gave us K5000 cards. So I brought this thing with me. So these are the K5000 This is a K2 card, and what you can see here, it comes with 2 Kepler GPUs. The K1 comes with 4 Kepler GPUs, but they are smaller.
Less number of CUDA cores.
Yep.
So the K1, I'm pretty sure, and correct me if I'm wrong, it's like 768 CUDA cores per GPU.
Yep.
And on the K2, it's 3072 CUDA cores per GPU. Is that correct?
Yeah, here.
1500 per GPU, so it's 3000 for the card.
1536. Yeah, it's on here.
Oh, it's on there.
It's on here.
Sorry. So 3000 CUDA cores in the K2.
We had to buy new cases for those cards because they're big. And so now we have gaming cases. My kids love that. So they think it's for the first time I have cool stuff in my lab. And well, that's what it is. So that's what we're using. Yeah.
No, we've got the actual cards here. We don't need to show that.
And this is what it looks like if you configure it with Hyper-V. So what you see here is it shows one of the Kepler chips that it's assigned to VM or to one of the VMs. But the thing is, it only gives it 80 meg per VM.
Well, it depends on, so within RemoteFX, you have a configuration setting on how many monitors and what resolution you want to support. And based upon the number of monitors you want to support, that's the VRAM allocation that it makes per VM. And I've asked Microsoft a while back, like, is there the capability to tune this or to allocate more VRAM if you want to sort of like give more GPU access to one particular machine? And I was told that that was not something that was planned. They're just letting RemoteFX and Hyper-V handle that. So. Right. Mm-hmm. And that's why I had asked if that was configurable, and I was told that's not configurable.
Because if I only have one VM on the box, and I have a grid card, I would at least want to use the 4 gig. Yeah.
Well, and from my perspective, and Microsoft can feel free to tell me that I'm completely wrong on this, but I don't think the design objectives for RemoteFX when they created this was really high-end graphics. It was not intended to do, you know, CAD engineering, that kind of stuff. Yeah.
Yeah. Yeah. Good. And this is how it works if you have GPU pass-through, because now you can really install the driver, the NVIDIA driver, in the VM, and the VM can talk to the grid card or the Quadro cards directly. So this gives you the maximum performance from the GPU.
Now, in order to use the GPU pass-through, you have to use a particular hypervisor. So in the case of Zen Server, you have to be, generally speaking, on 6.1 or later. They had some early support in it for 6.02, but 6.1 or later or 6.2 would be ideal. In the case of VMware, the official support for VDGA is not there yet. It is currently in tech preview.
Yeah, this
so
is
you
why it's
can
in
do
brackets.
GPU pass-through, but it's not officially supported at this time. So the only supported models for VMware today is VSGA, which is an API intercept. And the problem with the API intercept under VMware View is it's only supporting DirectX 9 and some early OpenGL up until like 2.1, I believe. They're not supporting the full OpenGL spec and the full DirectX specification. So it's somewhat limited.
Good.
I mean, the code is there. It is tech preview. You can use it now. It's just they haven't committed to when it will be finally production supported.
You can test it right now. You go to direct-IO and you just
Yeah.
this guy device path enumeration number and assign it to a VM.
Yeah.
In my experience at my home lab, that works until I reboot the VM, in which case it hard locks the entire hypervisor. So there's just something going on.
It's a little glitchy right now, but it does work.
So let's take a look at the 3D results for the next like 10 minutes. And here we go. The floor is yours.
So we did a couple different things. We took a look at a fairly simple DirectX 9 based a test being Google Earth. And we have the bare metal up here, of course, which is going to provide the best user experience on the K5000 card. We have a LAN-based Windows 7 with HDX 3D Pro, so this is dedicated GPU pass-through on Zen Server. Then we have RemoteFX vGPU under Windows 7. And over here we have Server 2012 with Zen Desktop 7 App Edition. So this is a GPU sharing, this is a GPU sharing through different methods, and this is dedicated and dedicated up here. And what you'll notice is that the HDX 3D Pro with dedicated is actually very fluid in terms of the user experience. These down here, you can definitely see some stuttering, but over the LAN, it's actually not that noticeable. It's quite usable, both with RemoteFX vGPU as well as with the Server 2012 Zen Desktop 7 App Edition.
The interesting thing that I thought from this here is if you have not such a good bare metal machine, you may run into a situation that your remoted session will beat, from a performance perspective, your local performance. But it requires high-end graphics cards on the host side.
Now, we also looked at doing DirectX 9 through Google Earth over some network conditions. And trying to do this over 2 megabit can be challenging because it's not a lot of bandwidth for high-end graphics. But the thing that really impressed me was HDX 3D Pro actually makes this almost identical user experience to bare metal. This is only going over a 2 megabit network, which to me was quite shocking. I expected this to be poorer than that before we ran this set of tests. And what you'll notice in the case of, in this case we did Zen Desktop 7 App Edition on Server 2012, and we're doing RemoteFX vGPU on Windows 8. Now the reason why we did vGPU on Windows 8 is because we can't do vGPU over network conditions on Windows 7. The vGPU support for RemoteFX, as you heard, only supports LAN connection parameters. You can set it to LAN and do it over an emulated network, but it's so horrifically bad in performance, it wasn't worth showing you the results. So we ended up going to Windows 8 in this circumstance, which I realize is not exactly fair comparing Windows 8 to Windows 7, but we couldn't do vGPU on Windows 7 and do a comparison. So we introduced Windows 8 for that. Then we tried to bring this up to some higher bandwidth to try to see if the RemoteFX or the Zen Desktop 7 App Edition on Server 2012 would start to close the performance gap and get a little bit better once they had more bandwidth available. And again, you see that the user experience on Zen Desktop 7 HDX 3D Pro is quite similar to bare metal, very, very good user experience. What you're noticing now is that the Zen Desktop 7 App Edition on Server 2012 and the vGPU on Windows 8 is actually getting much closer to the user experience. You still see some loss of frame rate. It's not quite as smooth, but it's definitely much better than it was under 2 megabits. So having the extra bandwidth available does make this a bit more usable on vGPU on Windows 8 and on Server 2012.
Click.
Yep. And then one last test we wanted to do with Google Earth was, what happens when we introduce some loss? So now we have 300 milliseconds of latency and 1% packet loss. So this is definitely a kind of near around the world type connection. And what's interesting about this is now that we have the packet loss, you will start to see a little bit of stuttering in the HDX 3D Pro solution because we are TCP based. And the Server 2012 Zen Desktop 7 App Edition is really stuttering a lot. Again, this is TCP based, so having the packet loss and having the high latency is making this one stutter quite a bit. Not surprisingly, the UDP-based RDP8 actually is doing a much better job in the loss conditions than what the Server 2012 and the HDX 3D Pro is doing. So quite a good job once you have loss involved. So let's jump to PowerPoint.
Let's see PowerPoint.
This is an interesting one.
That's an interesting, yeah.
So PowerPoint 2013 uses DirectX 10 for doing the slide animations. And so under Windows 7, you can't do DirectX 10 with vGPU. So you're seeing falling back to CPU-based rendering of all the animations. So it goes very, very poorly. We have over here Zen Desktop 7 App Edition on Server 2012, which with the GPU pass-through can leverage the DirectX 10 graphics. And you're seeing pretty much like you are with HDX 3D Pro, a near perfect experience over the LAN. But again, with the LAN, we have lots of bandwidth, and so it's kind of to be expected. But we also ran this same test over the LAN, and now we introduced RemoteFX vGPU 7 and RemoteFX vGPU 8 on Windows 8. And now that you have vGPU on Windows 8, we can do DirectX 10 and DirectX 11. And now you see in a LAN scenario, this is pretty much bare metal user experience. Yep. So the graphics stack on Windows 8 for RemoteFX is obviously much, much better than it was in Windows 7.
So it becomes very obvious that Windows 8 is the machine to remote into if you want to use RemoteFX.
And,
up.
sorry.
Yeah.
We also we purchased a professional edition of 3D Mark benchmarking software. Now, we don't like to do a lot of games and those kind of things, but wanted to see if we had a much stronger GPU-based benchmark, how would these solutions do? So this is based on a LAN. And so HDX 3D Pro actually doing a pretty decent job. Not quite as fluid as the bare metal solution, but definitely usable. And we also have the Windows 8 RemoteFX vGPU, and it's actually doing surprisingly well. And now this, again, this is a DirectX 9-based test, but because vGPU is not supporting the graphics rendering, actually this one, in this case, they support, they don't have support for the GPU in the Windows 7 scenario. And the last ones we wanted to do, just to highlight a deficiency in RemoteFX at this point in time, there is absolutely no support for OpenGL, hardware acceleration of OpenGL under RemoteFX. So we have no video available, even under Windows 8. There's no OpenGL other than a software 1.1. Here we have Server 2012 Zendesk 7 App Edition. Now this frame rate, of course, is not real, but this is GPU pass-through, but it thinks it's getting many more frames than it actually is. And HDX 3D Pro, pretty much matching bare metal performance, but again, this is on a LAN situation. And the last one is a WebGL Aquarium. And this one's interesting. Again, we have nothing on Windows 8 because there's no OpenGL support. On Server 2012 versus Zendesk 7 HDX 3D Pro, you'll notice both of them can run this because they both have a GPU provided to them in the hypervisor. The key difference is the frame rate, which you can't really see very well here. I may have to look at it on the screen to see the frame rate numbers. You're getting somewhere in the neighborhood of like 30 to 40 or 50 frames in the HDX 3D Pro. In the case of Server 2012, we're seeing about 6 to 8. So definitely, even though we're passing through GPU, the Server 2012 method of sharing it on a XenApp model does not yield anywhere near.
Hey,
Oh, there we
look
go.
at that. Huh?
It doesn't yield anywhere near the equivalent performance of what HDX 3D Pro does when you're trying to share the graphics.
It's like 50, yeah, between 30 and 40 frames here. But
no other users.
No
So
other
single
users.
user, they have access to the entire single Kepler. It's a Grid K2, but you can only GPU pass through one of them to a VM, so it's one entire Kepler for the Server 2012 box, but it's one user. So we're definitely not seeing contention for the GPU. It's just on Server 2012 trying to share it, you get less performance than you would if you were doing a Windows 7 machine with a pass-through GPU. So, okay, let's go back and do some quick summary.
Yep. Here we are.
So RemoteFX and RemoteFX Soft GPU, if you're on Windows 8, really has become head-to-head with HDX and PC over IP in sort of the task worker, knowledge worker, and some power user scenarios. And we say head-to-head, we mean in terms of user experience. Of course, the bandwidth on the wire isn't always the same, and we've been seeing in general that RemoteFX and RDP is using, in some cases, as much as 20 to 50% more bandwidth than what HDX or PC over IP is doing in the same situation. Obviously, we've already alluded to this earlier. If you want to use vGPU or soft GPU performance, you really want to be doing this on Windows 8, not on Windows 7. The graphics stack on Windows 8 is far superior to what is in Windows 7.
And we're really looking forward to do the same test with Windows 8.1, to be very clear, and Server 2012 R2, because that's the natural next step that we want to do, because we believe that the adoption rate for Windows 8.1 will be much, much better than it is for Windows 8. And so it's going to be Windows 7 or Windows 8.1, so that's going to be...
One of the most important things, I think, if you're doing some more high-end graphics work, is one of the biggest gaps for RemoteFX today is the fact that they only support OpenGL software rendering to the 1.1 specification. And 1.1 people haven't been writing to for probably 10, 15 years. Everyone is creating OpenGL code that is 2.x, 3.x, 4.x. So the biggest gap in my mind, if you're trying to do any kind of decent graphics for RemoteFX, is that there's no OpenGL support. Now, Microsoft says, we understand this is a gap. We haven't committed to working on it, but we understand the problem. We know that people want it, but there's been no committed information about when they may support OpenGL in the future. So that's up in the air a bit. And Microsoft does not provide a dedicated GPU solution. If you want to do high-end graphics, you cannot do it on RemoteFX today because really, really high-end graphics requires you to do GPU pass-through and have full access to the GPU. RemoteFX gives you a little slice of the graphics processor. Now, something that we've not been able to do any testing with yet because the code is not yet complete is NVIDIA and Citrix have been collaborating together on virtual GPU technology where you actually are able to load the grid driver into the machine but still share the GPU across multiple VMs.
It requires a sort of a broker in the hypervisor that does the brokerage of the individual VMs communicating with the GPU.
So that's stuff we're hoping to do later on this year, beginning of next year when that code becomes complete. I believe there's going to be a tech preview that will be coming out in the next few months. So once that ships, we'll start doing testing with that and hopefully have some results next year on the NVIDIA and Citrix vGPU. But the general problem there is, to my knowledge at this point, no other vendors have committed to doing virtual GPU in their stack. So we'll have to wait and see what VMware's plans are, if they're going to support virtual GPU, if Microsoft will support it. I'd expect personally Microsoft to be the last people to support it because they have the whole Callista technology and that would kind of be a completely different approach than what they're doing. So, but VMware may very well end up adopting virtual GPU as well. We'll have to wait and see what happens.
But the good news is, because the question at the beginning was, is RDP8 and RemoteFX ready for the enterprise? Yes, for many scenarios they are. And it's more scenarios than ever before. This is the good news. But there are still high-end scenarios where it requires, well, the other protocols, because they do a better job with OpenGL and supporting direct access to the GPU.
And one of the most important takeaways that we did not include in the summary here, but I want to make sure I clarify for everyone. Microsoft has the vGPU technology, and then they have the classic RDP. If you're not doing high-end 3D graphics, you just have RDP7 or RDP8. The most important thing to know about RDP8 is a free download, and you can apply it to every single Windows 7 endpoint in your organization. You don't have to have enterprise like you do for vGPU. You don't have to have it on a hypervisor or Hyper-V. You can do it on physical endpoints, desktops, laptops, VMs, everywhere. And it is markedly better in almost every single situation than RDP7 is. So I highly encourage you guys to go out and download the 2 hot fixes that enables RDP8. You need to configure it in Windows 7 in group policy or in local security policy to enable it because it doesn't turn on by default. But modify that in group policy, roll out the patches, and start using RDP8 within your internal network environments.
And it runs on other hypervisors as well. That's the question that is always asked in the forums. Does it work on my, VMware ESX
It will work on VMware, it will work on Hyper-V, it will work on Zen Server, it will even work on physical desktops and laptops. So put RDP8 everywhere in your organization. It is fantastic. Microsoft really did close the gap against HDX and PC over IP for all of the lower end information worker, task worker type people. It's pretty much neck and neck for most of the use cases.
Okay, that's about it.
Thank you very much for coming.
Thank you.
Thank you.